Welcome back, or if you're just watching this for whatever reason, I hope that I am of help. Okay then, so this is, oh, I like this one. Okay, then we know our log rules. Base of a number, take our stuff in the middle, and log of something is the same as me saying log base 2, 8. You'd say, heck, I'm thinking about this, 2 times what power gives me 8? So you'd say 2 times, maybe 2 doesn't, no, that's 4. 3, there we go, done. And then I always think of this example if I ever get confused about logarithms. And then you can extrapolate this to help you with any problem, really. So I say, heck, log base 2 of 8 minus log base 2 of 4. And you'll say, heck, this is just 2 cubed. This is 2 squared. And the answer would be, let's think about this, 3 minus 2 equals 1. And another way of having a look at this is 8 over 4 equals, what's that answer? 2. And then log of 2 base 2 of 2 is just 1. And it's the same thing. So let's link this back to our problem here. I will remove all this because this is probably me rambling on a bit in irrelevant stuff. So yeah, sorry about my loud keyboard. It's an angry monster. So let's have a look at this. Log base 3 of x, and let's express this. You'd say, heck, Peter, this is lag. Been playing too much Call of Duty. 4x plus 7 divided by x. And then we can cancel this down clearly because this is messy. Log 3 of these x's, this splits down. Oh, some of you might not be the best at cancelling down. It's alright, I'm here to help you. 4x, we can split this into 2 equations. These 2 cancel. This remains the same, so bracket open, 4 plus 7 over x. And voila! That's what they want from you. Okay then, hence. I love the word hence in papers because they just want you to think about this part here to help you get the answer in here. Well, not that gap, that would be a bit small. So they say, here's your answer. Let's solve this. So you scroll down and you say, you know, I'm gonna be awesome. I'm gonna answer this. And you think about another property of logs that, yeah, I might as well explain it. So let's look back to our example. So log of base 2. I like my bases of 2. Let me make this a bit simpler. 2 to the power of 3. You say, heck, why are you being an idiot? It's the same thing as that's just equal to 2 to what power? Heck, that's just 3, isn't it? Since that's just 8. So you're like, why are you so silly? But then think about it. This in itself is just 1. If I move that there, 3 times 1 equals 3. I hope you would understand. So then let's extrapolate that property again. So they tell us that, let me scroll up a bit more. Okay, I've remembered that now. So log 3 for x. Oh, why am I bothering to write all that out? They've given that to me already. I'm loaded. I've sorted this out. 4 plus 7 over x equals 2. And then you'll say to me, that's interesting. And then you take log 3 of either both sides, or you just say that this whole thing must equal to, well, let's just take logs of both sides. Let's do everything to the power of 3. So this log times log 3 blah blah blah, this just gives you what's in this box. Okay, we can kill these 2. But this number here, 3 to the power of 2, is 3 times 3, or 9. So we would just say that 4 plus 7 over x is 9. And cancel this down, so subtract 4 from both sides, so you get 7 over x equals 5. Okay, that was a bit of a blunder. Divide times both sides by x, so 7 equals 5x. Move it back over, 7 over 5 equals x. Voila! Or let's express this as a number, 1.4. And you can leave it in fraction form. Everyone loves fractions. And now, let's look back at our question. That's the answer to the second part. Using the trapezium rule. Oh, the trapezium rule. What? Good old friend of mine. I despise it. I hate you. And we haven't covered it yet, and it would be silly trying to differentiate, even though, no, integral, I mean, because you can do it, but why would we bother do that? So we're going to just say, you know, I'm just going to look at my formula book and answer this. So let me just open a completely new question, because don't shout at me, computer. This is question 5. Load. There we go. That'll do. That gives us more room to work. Okay then. So the difference, what they give us, is that we take our integral of a number, so in this case 9, and another number 3, of whatever function we have in respect to x. So in this case we've got an x here in respect to x. We're respecting it. Put my fist forward and fist bump. And then we take half the height, and height, they also give you this. You might not realize this, where b minus a divided by n, and in this case we want 2 strips. 2 strips. Both of widths 3, so we can just say the height, since we're using trapezium sideways. Here's my curve, okay, an abysmal curve. Draw there. This, if this was a trapezium, okay, it looks more like a train that's been lost in the woods or something. This would be our height. So similarly, it's just our width. Okay then, so let me remove all of that because you're just getting in the way, since they give us the width. And I would just sub in here, in my new brackets now, I would sub in 3. Open the brackets again. Okay, open new brackets. We take our y of first term, which would be log 10 of, 3 in this case, because that's our first term, plus 2 times, okay, I'll show you the beauty of it in a sec, calm down, don't jump out your seat. Okay, log of, well, 3 plus 3, since it's width 3, is just 6, log base 10, of course, plus log base 10 of 9. Okay then, well, if we plug this into a calculator, we get the answer, but that's a pretty elegant way of doing it, if you can ask me. And you would sub this into your calculator, all of this, and you would say, hack, that is genius. And then you would get an answer of 4.48. I've done it on my calculator, and you'll see in a sec that it works. So let's think about this. Here we have our line, magic line, and I will draw a point here because I don't know what the actual function is. I haven't gone on Wolfram app or anything and had a look. So when we trapezium rule, we take 2 points and we split it into 2 trapeziums. And the genius of it is that we take half times height of, since it's a trapezium, it's the width, so we take that. And we take our first y term, which is one side. Yeah, one side, the bottom side, the end point of our integral. Then we take the second, the end side, which is here. But then you say, why there's 2 here? Why there's 2? And I would say, heck, we use this once here for this trapezium. Let me use a different color to highlight my point. Once here for this trapezium. And then again here for this trapezium. And then, as one could say, that's genius. And that's how we use a trapezium rule, and that's a small explanation of how it works. And hopefully you've understood what I've been going on about. And let's have a look at the marks. Let's have a look at marks. There we go. Ta-da! We did our logs earlier. They went well. We got the marks for that. Second one, that went well as well. Look, they even put the 2 there. Isn't that great? And if you attempt to use it and don't get it right, then that works. And if you get correct unsimplified expression, then you probably get fractional recalculator. Then you only get 1 mark. So try and make it in decimal form if they ask for area. And that should be it. So hopefully you've enjoyed it. And any feedback, leave some on the YouTube page or whatever. So yeah, thank you very much and have a good evening.